Hi everyone. Today I will be presenting on the topic of rotational inertia. This presentation was created by me, Valerie 1. I'm in the section 1802 of English 3, and my English teacher is Dennis Urbina. First one, the inertia is a fundamental concept in physics that describes an object's resistance to change in its state of motion. More specifically, inertia refers to an object's tendency to remain at rest or in uniform motion in a straight line unless acted upon by an external force. Example of inertia. Here is a simple example to illustrate inertia. Imagine that you're standing on a bus that is in motion. When the bus suddenly brakes, your body tends to continue moving forward, resisting the change in motion. This is a classic example of inertia. As you look in the image, rotational inertia is a property of an object that can be rotated. It is a scalar value that tells us how difficult it is to change the object rotational velocity around a given rotational axis. Now, what is the rotational inertia equation? As you look here, the rotational inertia equation for a system of particles is given as equals to I equals the sum of m times r squared. In this equation, I is the rotational inertia, m is the mass of each individual particle, and r is the distance of each particle from the axis of rotation. The sum is taken over all the particles in the object. We can see four different objects rolling down an incline. Even though the objects may have the same mass and radius, they will reach the finish line at different times because their mass is distributed differently relative to an axis of rotation, giving them different moments of inertia. For example, the solid finish first at 1.1 seconds, while the hoop finish last at 1.3 seconds. It's a small difference, but they have a difference. Whatever they are, is a small quantity. You can look here at the time and the mass in this one, in another example of the rotational inertia. Finally, it's important to know that other name using it for rotational inertia, the most common alternative name is moment of inertia. We don't call it, you don't hear people call this like rotational inertia. We'll say that moment of inertia, and it also sometimes refer the second moment of mass. Then normal people just call it inertia or moment of inertia. And why we call the second moment of mass is because it depends of the length, the moment arm square or r square. This final diagram shows the equations for the moments of inertia for various common geometry bodies, such as a solid cylinder, a cube, and a sphere with respect to different axes. And that was all my presentation. Thank you for your attention.